by far the most important thing for today is knowing these. Because yesterday we took derivatives, today we're going to take antiderivatives. So it's one of those where if you want to be able to drive backwards, you got to be able to drive forwards. Driving backwards is still harder, but the more practice you've had driving forwards, taking a derivative, which is why we did some warm-ups today and why we did some of the homework, the easier it will be to drive backwards. So it's a pretty quick turnaround that yesterday we learned to drive forward, today we're going to drive backwards. You know? Congratulations. We can do this.
We're getting a driver's license today?
Yes, you're getting our backwards driver's license today.
Well, that's part of getting your driver's license.
Let's skip all the intro stuff and just jump to the rules again. Jump to this box. Let's see. And again, this is where if you know the derivative rules, you can, you know that this is sine, tangent, and secant, but what order are they in? So which one of them looked the closest to that?
It goes in order sine, tangent, and secant.
How did you know that? Just because it's the same order, or do you recognize?
Look,
Right, it's a square root, and it looks like 1 minus the argument squared. So if you know the arc-sine derivative rule, then hopefully you recognize that, all right, I'm not exactly sure how this works, but that came from an arc-sine problem. Now, what's a little bit new, came from an arc-sine problem where u was the argument, and it was u over a. That's the kind of the different part today, is that over a stuff.
I'm excited about that little note you left in the dotted box.
Yes. And then plus c.
Oh, yeah.
Second one, that looks like the easy one where there's no square roots involved, so that's arctangent. And again, it's u over a. But this one has a little extra special something to it. 1 over a out front. So sine doesn't have the 1 over a, but tangent does. So this is among all the many places to get confused, this is one of those places. Now, how I remember which one has the a over front and which one doesn't is simply that tangent has an a in it, so it gets an extra a. Tangent has an a in it, so it gets 1 over a out front. Arcsecant, but before we even write it, integrals yielding arcsecant functions are not tested on the AP exam. Yay. So we'll write it down, but probably not going to use it.
Too much, at least.
In fact, none of the examples will have it. So kind of gray that one out. That one's not as important. I need to double check. You can ask me that on Monday.
You mean Tuesday?
Tuesday, yeah. So all of these are about recognizing, looking at number 1 and thinking back. Really, you don't memorize the integral rules. You memorize the derivative rules so that you can recognize what's going on. So again, I don't have really the integrals memorized so much as I have the derivatives memorized. And I know, square roots, so it's not tangent.
Mm-hmm.
And we don't deal with secant, so it's got to be sine.
Mm-hmm. Yeah.
So it's the arcsine of something. That's the first. Then we got to figure out, well, what was u and what was a?
Well, a was 5.
So a is 5, because a squared would give us 25.
U was 2x.
And u would have been 2x. Now, if u was 2x, then that introduces a chain rule issue for us, because that means du is 2 dx. So we're back to some u substitution here. Put a 2 and a 1/2. So 1/2. Some people are going to write the answer straight from here because they already know it's arc sine. But I'll do all the substitutions here. A squared minus u squared. So it's arc sine of u over a, 2x over 5, and that 1/2 is out front. And that 1/2 is the result of the chain rule stuff and u substitution stuff, not from the formula. That's just the u substitution left over, and then plus c. Again, you have to be able to recognize which one's that one. What's that look like?
Arctan.
Arctan. So I'm going to go ahead and write arctan because I'm pretty sure it's arctan. So that means u squared plus a squared. So what's u equal to?
X.
X. Oh, that's good news because that means there's no du dx business going on.
But
A is going to be a little bit weird.
Square root of 2.
Square root of 2. It's all right.
What's with the 3 on top, though?
What can we do with that 3 on top?
You move it out front.
Just move it out front.
Alright.
And again, I don't have any dx stuff to worry about. I mean, you can write it
Just
out,
kinda
but
plug it in. Yeah.
so we're good. It's arctan of u over a.
There's one
But
over
don't
A.
forget there's a 1 over a out front, so we need
Becomes 3 over square root
3
2.
over root 2 plus c. And we don't have to fix square roots in the bottom.
We don't have to rationalize.
Yeah, like pre-cal, you have to multiply top and bottom, but we're not messing with that.
We have become slightly narcissistic.
Okay, then things get
Dicey?
a little bit weird here on number 3. So does that look like any of the ones we've been dealing with?
Tangent?
Tangent? Kind of. That's a good answer. Tangent?
Question mark.
Kind of.
But that looks like
Arctan?
a u squared?
Yeah, it looks like a squared plus u squared. So that would mean u is cosine. So let's see if this works. A is square root of 7, but we don't do anything else with a, so we don't care if a is something weird. That's
So
fine.
would it just be sine out front?
Well, you can't
do
put
that?
something out front that has a variable in it. The only thing you can slide out front is constants.
Darn it.
But we got the u du thing to worry about, or not really worry about.
du
This is good.
Negative.
Du is negative sine. And
So you just plop a
that's
negative
a
on
very good thing, so we can put a negative on there. So negative antiderivative. Let's see, that would be du over a squared plus u squared. So now that's definitely arctan. So instead of question mark, it's exclamation point. Yes,
Arctan.
arctan. How exciting. So negative 1 over a
1 over square root 7.
arctan u over a cosine of x over square root of 7
Let's see and leave alone.
plus c. Ugh.
Don't touch it.
Now, that was tricky enough knowing that we're doing arcsine and arctangent problems. If you just saw that on your own, you would probably, most of you, and I would do it too the first time I saw it, I would let u be the bottom. And because I'm thinking, oh, that's good because derivative cosine is something to sine. But if u is the bottom, I mean, this is wrong. This isn't going to work. du is 2 cosine x sine x. And negative that. Like that doesn't fit what I need it to fit. And so you've got to recognize if it's just u squared in the bottom, that's a tangent thing. If it's a square root, then maybe it's a... So number 4, it's like, I think it's arcsine because it kind of looks like arcsine.
Well, you said none of the examples had arcsecant.
So arcsine looks like u squared minus a squared. Whoops, other way around. A squared minus u squared. So a is 3, that's easy. What would u need to be to make this work?
X squared.
X squared?
Didn't want to say anything like that.
No, that's good news.
Oh yeah, we just gotta plop a half over.
Du is 2x dx. So yeah, this will work. I could put a 2 on there and then a half out front. So du over square root of a squared minus u squared. So yes, arcsine. 1/2 arcsine u over a, x squared over 3, plus c.
Yay, next.
Again, it's not even easy when I'm doing it, but when you've got them on your own, ooh.
On the test, like, are these gonna be like multiple choice, and like, are they gonna look like that, or are we gonna have to?
Okay, great question. Yes, most of them are multiple choice,
Sure.
because there's 27 multiple choice and 4 free response, something like that, close to that. And so what do you mean, are they going to look like that?
Like for multiple choice answers, like when it asks a question like this, are the multiple choice answers gonna look like that, or are we gonna have to like configure it to something else?
There, you can't configure that to something else, so it'll look like that.
Okay, perfect.
Would it be like limits?
I mean, there's probably some on there that are limits. Number 5. Any thoughts on what that maybe looks like? Okay, so maybe arcsecant because there's something out front, but there's not an absolute value on it.
Yeah.
And
X can be.
we're not going to do arcsecant, so not worried about it.
On the AP does.
So other than that x out front, square root of 1 minus something squared, that looks like arcsine. X I'm not sure about, but u squared, a squared minus u squared. A is 1, that's easy. U is natural log. By the way, if you ever see natural log inside of an integrand somewhere, you're almost always, stick the almost in there to protect myself, but almost always going to let u be something with the natural log, because we don't have an antiderivative of natural log, so we let u be something with the natural log and hope that it works. So if u is natural log,
E.
what's the derivative of natural log?
1 over.
1 over.
Yeah.
1 over x. And now I know where that x came from. Like that's a consequence of the chain rule from natural log. Du over square root of 1 minus u squared. Or I guess I could have put a squared minus u squared. So arcsine u over a, natural log of x over 1. Oh, that was not really necessary. Plus c. And that just, I mean, that's fine as an answer. It just looks so terrible, I'm going to rewrite it. Okay, so dedicated to writing the formula, u over a, I wrote u over a. More fun is on the
Oh,
way.
what
But
is-
6 isn't bad. 7 and 8 are.
7. 7 is a
What does 6 look like?
arctan.
Arctan, like something squared plus a number, looks like arctan. No square roots involved, so arctan, maybe? So we're thinking u squared and a squared. I mean, they set it up really nice for us here. That would mean u equals x plus 3. du is dx, so that's good. Don't have to really worry about it. A is 5. So that's du over u squared plus a squared. So yeah, that's arctan. U over a, x plus 3 over 5. But for arctan, don't forget the a out front. Tan has an extra a in it, so you get an extra a in there, your answer. Okay, that wasn't
Too horrible?
too bad. Again,
7.
these aren't awful because you're basically picking between two choices right now. Again, if we, on Tuesday when we scramble them all up and you've been doing some other u substitution and you hit that, will your brain recognize that as arctan, or will you start down some other weird path and forget that arctan is a possibility? The good news, Mia, on the multiple choice stuff is probably, and maybe you do this anyway, but probably when you see that problem on the test, like look at your answer choices.
Right.
And sometimes we did it both ways. Like sometimes the answer choices to this one are all arctan. So you know it's arctan. You just got to figure out, is there a 1/5 there or not? Which way does it go? But other times your answer choices are arctan, arcsine, natural log of that, and something else goofy. And so occasionally, if you recognize that that's got to be arctan, you look at your answer choices, and only one of them is arctan. It's like, well, I guess that's it. Circle that one and move on. Maybe check it later, but so that there's sort of two ways we can test those questions. One is, we'll assume you know it's arctan and check to see that you can get the details right. The other is the big picture question, do you recognize that that's arctan? So maybe that's helpful. Number 7.
Why?
It's like, when you first see number 7, maybe the first instinct is to let u be the denominator, because we've done that before. But then du is 2x plus 4. And right, I can't add a 2x plus 4 in the top. That's not allowed. So, that doesn't work. Probably the first attempt for most students, though. Boy, if I could sort of make it look like number 6, though.
Oh, you're saying we have to factor.
No, not factor. If only I could make this first part be a perfect square, so that I could write it like number 6 is written.
Completing a square.
Completing the square.
Oh.
It's like, completing the square.
That's easy.
So what do I do?
How to do that?
10th grade throwback.
Trey, what do I do?
Landon, tell him. Trey, tell him.
Trey, you said it was easy. I want you to tell me.
All I know is that there's gonna be something somewhere.
It's going to be something somewhere.
It's like it's either plus 16 or plus 8 or plus 4.
Okay, you're right. It is one of those things.
One of those. That's all I know.
I'd say it's plus 8.
No, because you have to divide the b by 2. Yeah. So
Yep.
it's 4, so it's plus 4.
So it's
yeah.
plus 4. Now, previously when you did this, you were solving equations. So on one side you put plus 4, and on the other side you put minus 4 to balance each other out. No, excuse me. It was on an equation, so you did plus 4 and plus 4.
Mm-hmm.
I just gave away the answer for what you're going to do here.
Mm-hmm.
Here, you added 4 to this part of the line, so if you want to keep that in balance,
You gotta take it away.
you got to take it away on the other part of the...
I really don't like using that.
So that's x plus 2 squared plus 9.
Wow, it's like it was rigged.
It's like it was rigged to work. What does that look like now?
Arctan.
See if you can finish that one. See if you can finish that one. So arctan, after we complete the square, of x plus 2 over 3, u over a. Arctan has the a out front though, so 1 over 3 plus c.
Good job.
I don't like that.
Next one. I mean, it looks like
we could try to complete the square.
yeah, we could do complete the square on this, I think. We got some extra powers going on in there, but b over 2 is negative 3.
But then we gotta
So we'll add 9 to complete the square. But if you put a plus 9 in the bottom, then you need a minus 9 as well. B over 2 and square it. The key part of complete the square is half it, square it, add it. HSA. I hope my
Like,
pre-cal
almost like
students
close
remember
up.
that.
I wasn't in pre-cal students.
I know. I'm looking at my
You're veterans.
3 people that I had for pre-cal last year. They're keeping their head down like, I don't remember that at all. HSA, half it, square it, add it, Ty?
What?
Yeah, that's what I thought. Landon, maybe? Landon's a thumbs up. Kristen, half it, square it, add it? Eh. Oh yeah, Julia, you awake over there?
Oh.
No, just no. So I still think this is going to work. Because the perfect square now is x squared minus 3 squared plus 4. Dx, so that's u squared and a squared. They rigged it so that a was easy. U not so much. X squared minus 3. What's du? 2x. And now we understand why there was an x in the top. So 1/2 du over u squared plus a squared. It's definitely arctan now. Arctan u over a.
Times 1/2. Well, that's for the front of it.
Yeah, there's a 1/2 from the chain rule stuff, but there's also a 1 over a component as well.
So it turns into a...
So there's a 1/4. You can write it as 1/4, or you can just leave them separate to kind of note that one of them came from the chain rule stuff and one of them came from the arctan rule.
Do you know if there's any arc secant on the homework?
Let's look and see. So worksheet number whatever is next. 6. Let's look and see.
Recording so that the people...
Yeah, let's keep recording and let's look at worksheet 6. So I'm thinking that looks like sine, 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 with the u substitution maybe for u is t squared, I bet. And then that looks like, you tell me, what's 5 look like?
If you're asking me.
Sine. Or arctan.
Tangent, tangent, tangent.
What's with the limits?
Yeah, that's what we're calling.
Well, when you get to the end, you top minus bottom. That looks like tangent. There's a complete the square. Tangent, sine. So I haven't seen any arc secants yet. That looks like a sine. That's a complete the square. That looks ugly. Do you recognize what 13 is?
You didn't what?
Tan.
Looks like arctan. What would U need to be?
E to the X minus 1.
E to the X minus 1. And then DU would be the top, so it does work out.
Okay.
So that would be arctan.
Arcsecant.
And then another arctan, and then another arctan. No arcsecants, all arcsines and tangents.
Okay, good. As it should be.
And then you could start worksheet 7 if you want. It's just very mixed practice. So like, look at number 4 on worksheet 7. You don't even have to look on your own. Look at mine. This is what I'm talking about. What does that look like?
Arctan.
It looks like you substitution stuff.
What would you let U be?
Because you have X
plus
two.
2.
You saw the X on top.
Yep, and then DU would be the what you need. But it also kind of looks like arctan, so
It does DU2X plus 2. So
It's to mentally screw with it.
as opposed to number 7 before you walk out and leave. What's that look like?
that looks like
No.
because you substitution. You sub.
It looks like arctan. The 5 I can get rid of. That's no problem.
Here's I got a question. On the final,